Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, today I want to take you through the tips on actually how to pass Maths paper 1. You know, based on my experience being a Maths and Science tutor, or I can say teacher, there's most of the things that I actually encountered in terms of like most of the learners, why are they not getting good marks, particularly in maths? Ladies and gentlemen, let me talk about the content gap. If you're doing maths and let's say you are having a content gap in terms of let's say you're supposed to have to understand or to know things that you're supposed to have learned in grade 8, grade 9. For example, when we talk about exponents and such, honestly speaking, ladies and gentlemen, a learner who's struggling with like having a content gap in exponents. Let me just talk about exponents and such. Would be a challenge in understanding, particularly like in getting good marks in maths, particularly maths paper 1. Because guys, ladies, like things like exponents, these are the key for maths. Because in most of the instances, we use exponents in solving problems. For example, in most of the cases we used, like, you know, everyone who has done maths will tell you that when you take x, you multiply with x. This becomes x squared. But it is of importance to understand, why are you saying x times x is x squared? It comes from exponents. So it's very important for a learner, if he or she has a content gap in terms of like having to understand maths in grade 11, it's now in grade 12. So it's very important to go back to the grade 11. You can just get a textbook for grade 11, or maybe find someone who can actually remind you in terms of the basics. It's very, 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 very important. So this is the first one that I strongly believe a learner should be able to understand. Then secondly is the issue of understanding algebraic expressions. This is a grade 10 work actually, but it started from grade 11, grade 9, where we used to understand like how do you identify a term, how do I identify a variable, how do you identify a coefficient, and the likes of a constant in an expression. Very important. And also, even though you know that you understand the terms, like what are the types of expression? For example, we have binomial, there is trinomial, and the first one I forgot to write is supposed to be monomial. It's very important for a learner to be able to understand these things. And again, when you're dealing with algebraic expression, let me just make it, it does not matter which grade you are in, whether you're in grade 10, 11, or 12, you need to be able to understand these basics. For example, being able to determine the products. Very important. We still have learners who are in grade 12 who don't understand how to find the product. And it becomes a burden, like to solve questions, because somehow you'll end up using quadratic formula time and again, because you don't have the basics. For example, imagine when you're taking a binomial, we are getting the product between the binomial and binomial. And also, for example, binomial and the trinomial. Let's say we have x squared minus 2xy plus y squared. This is an example. And in some instances, you can also have the squared trinomial. Imagine you have binomial, you have something like this. Then these are the things that learners should be able to understand. And within this, all things that I've actually explained, they come from exponents. So which means exponent is the key. Because timelessly, so we keep on using exponents time and again. So it's very important for a learner to know exponents. Whether you are in grade 8, you're in grade 9, or you're in grade 10, 11, 12, you need to be able to understand these basics. Very important. And the only way to understand them, it's either, hence I said, it's either if you're in grade 12, you must get a grade 11 textbook. Try to remind yourself with these basics, because somehow, you'll be using them. You'll be using them in answering questions. So these things are very important, especially the exponents. Very, very, very important, ladies and gentlemen. That's why I felt it's important for me to actually try to assist others, or to just try to assist others in terms of understanding exponents. Right, number one, you need to be able to understand like the notation of an exponent. How do you actually write the exponent? There is a video that I've created for grade 8 and 9 for the exponent. You can also visit that video, and at least it will also assist you in understanding exponents. We know that exponents are actually written in the form of a, and on top of this a, like we can just put a variable for now. So the whole of this is called the base. It's very important to be able to know that this is the base, and this, it is the exponent. In another book, they call it a power. In another book, they call it an index. It's very important for a learner to know this. Yes, it might sound so like silly, but it's very important for a learner to know exponents. Very important. Because remember in the previous grade, like exponents, for example, if you have 2 to the power of 3, 3 is the exponent. And this exponent, it's actually telling us that how many times should we repeat the base. So it means we can repeat the base 3 times. This is the same as 2 by 2 by 2. So I think it's very important to know the laws of exponents in particular. Very important, ladies and gentlemen. I mean, if you want to enjoy maths, you need to be able to understand exponents. Number one, there is a law of exponent. Let me write it as law number 1, which you usually call the multiplication law. And this is one of the most important law that is used in maths. That says, before I talk about the law, let me try to explain what does this mean. This just means that it's a raised to the exponent of x. Or you can say it's a is raised to the power of x. Or you can say a raised to the index. So it depends with your, like how you like depends with your choice. So I can say it's a to the power of x, a to the exponent of x, a to the index of x. It's still the same thing. So according to the multiplication law, it says when you have, let's say you have a to the power of x, I'll just use the power for now, and you multiply this with a to the power of y. Bear in mind, multiplication in maths, it's that we use brackets, or we use this, or we use a dot. This has to do with multiplication. Right, now, it means now, when you are given this, according to the law of multiplication, it says, when you are multiplying 2 exponents, we'll just generally call it an exponent. When you are given 2 exponents, according to the law says, Under multiplication, if there is multiplication, when the base are the same for multiplication, you just take one base and you add the exponent. These are the exponent. X is an exponent, Y is an exponent. You just add the exponent. That's why with this law, we are able to know that when we have X times X, not by cramming. Remember I said you don't have to cram, because you see a learner always, when we say what is X times X, they will just say X squared. Then the question is, why are you saying the answer is X squared? He or she doesn't know that. So it doesn't help. You need to understand. So it means if you have X times X, the exponent here both is 1. So since the base are the same, then we're going to take one base and we add the power of the exponent, which gives us X squared. That's why when we have this, even if let's say you have X to the power of 2 times X to the power of 2, there's no need to think this is just X to the power of 4. We are concerned about the exponent because the base are the same. Even if we say X to the power of 5 times X to the power of 3, you just take one base and you add the exponent. This is maths, ladies and gentlemen. When you talk about maths, you're talking about exponents. And most learners take this for granted. It's very important. But remember, this law does not apply. It does not apply when the bases are not the same. It only applies when we have addition. That's why if I'm going to say multiplication, you find the learner in grade 12 when we say what is X squared plus X squared, then the learner will tell you this is X to the power of 4, which is wrong because this plus is not multiplication. So this learner is actually using the multiplication law on the addition sign, which is wrong, which is actually wrong. So these are the misconceptions that most learners do in the exam, and they lose a lot of marks by not understanding the laws. So it's very important. I felt like I felt I should just create this video to actually assist you in understanding this. Remember, don't take them for granted. Exponents are very important, ladies and gentlemen. Number 2, law number 2. Law number 2 is a division law. That says when you have a to the exponent of x, you divide by a to the exponent of y, or to the power. The law says when the base are the same for division, you just take a base and subtract the exponent. You take one base and subtract exponents. Very important. So what is our base there? It's a. Our exponent is x and y, but how do we subtract the one in the numerator minus the one in the denominator? Very important, very important. That's what I'm saying. This is for all the grades. Actually, grade 8, grade 9, grade 10, 11, and 12. You need to know these things. Imagine, look, in grade 8, we used to have something like this. X to the power of 3 divided by x to the power of 2. But in grade 8, we used to say, okay, fine, it means the exponent is 3, it means we have to expand the base 3 times. So it's going to be x times x times x. Then divide this, it's going to be x times x. Then now, with this, we know it means the first one will divide, second one will also divide, and this will remain with x. So it means the final answer will be x. You see, it's easy. But we will not keep on using this method, because imagine when you have x to the power of 10 or 100, you have divide by x to the power of 20. Are you going to truncate the x 100 times? It will be a tedious work. It will be a tedious work. Imagine doing this 100 times. It will be a tedious work. To avoid doing this, that's where they introduced this law. To minimize this. So it means we know when we have x to the power of 100, we divide by x to the power of 20. Now the bases are x, and the exponent is 120. So the law says when the bases are the same for division, you take one base and you subtract the exponents. which will give us x to the power of 8. Same applies with the first one where we said x to the power of 3 over x to the power of 2. The bases are the same. You take one base and subtract the exponent is 3 minus 2, which will just give us x to the power of 1, which is just x. A learner who wants to enjoy maths should be able to understand exponents very well, should master exponents very well. Very important, ladies and gentlemen. Law 1, the multiplication law. The law 2, the division law. Then we also have another law, which is law number 3. You know, I'm starting with the ones that are important for now, which you need to first, you must understand them in order to enjoy maths. Sometimes it's because of the content gap that makes you not to understand some of the concept. And I know nowadays, you know, when you are addressing things like this in class, some learners, they don't have that energy of asking questions. And which is becoming a problem because you allow the tutor or the teacher to proceed with the lessons, but yet you know you don't understand. I don't encourage that. But nevertheless, you need to spend time on exponent, ladies and gentlemen. Exponents are very important, are very, very, very important. That's why if we were to talk about algebra as a whole, I generally tell my student to say, a learner who's good in algebra, who is good in maths, particularly if he's doing maths paper 1, because most of the questions he or she will have to use algebras. So it becomes easier for the learner to even get a distinction in maths. Law number 3. Where we have a base with multiple exponent, very important. One base with multiple exponents. That's what I'm saying. You need to be able to understand which one is an exponent and which one is a base. Right, there's a law that says when you have a base A with an exponent of x, but still with another y. You see, we're having multiple exponent. X is an exponent, y is also an exponent. The law says when you have a base with multiple exponent, you just write the base and you multiply those exponents. You multiply the exponents. Why are we multiplying? That's the question. Why are we multiplying the exponent? Imagine we have this. Look, if we have 2 to the power of 3, this is the same as 2 times 2 times 2, 3 times. But when we have 2 to the exponent of 3 or the power of 3, but everything to the power of 2, what does this mean? 3 is an exponent, even 2 is an exponent. So it means we can start with this to say we can repeat this 2 times. So this will be 2 to the power of 3 times 2 to the power of 3. You see, I've repeated 2 to the power of 3 2 times. And you see that once you see this now, it needs multiplication law. And we know under multiplication that when the base are the same for multiplication, what do? You take one base and you add the exponents. And this is the key, guys. Actually, law 1, law 2, and 3. These are the keys in maths. So you see, this becomes 2 to the power of 3 plus 3, which is just 2 to the power of 6. You see, to avoid doing this, you just have the 3 and the 2. By using this, we're going to have 2 to the power of 3. Everything to the power of 2. This is just 2 to the power of 3 times 2, which is just 2 to the power of 6. You see, it's the same answer. Because with this method, imagine when we have 2 to the power of 3 to the power of 10. So it means you have to make 2 to the power of 3 how many times? 10 times, which will be a tedious work. So to avoid that, you just multiply the exponents. This is the key, ladies and gentlemen. Law 1, law 2, and law 3 is the key for maths. In sections like sequence and series, those were in grade 12. Sections like financial maths, even functions, the graph, somehow, you need to know exponents. Very important. Very, very, very important. Then also have the law number 4, which says you have multiple exponents, no, multiple base. This time around, you have multiple bases with one exponent. So I believe you understand. Let's say you have A and B, these are the base, but all to the power of n. Let me just use x. All to the exponent of x or to the power of n. So this is the same as A to the exponent of x times B to the exponent of x. And it's very important, guys, to understand this, which means when you have two bases that have the same exponent, you can multiply them back. But you see in the exam, you find a learner given this, let's say, this is an example. Let's say is given this question, Tn equals to 4 into 3 to the exponent of n minus 1. It's just an example. Then at the end, suddenly the learner do this, then say 4 times 3 is 12 to the exponent of n minus 1. Already, it means if the learner is going to continue with this, it means the question is whatever you will be solving will be wrong. Because look, 4 has exponent of 1. 3 has an exponent of n minus 1. There is no way you can multiply 4 and 3 if the exponents are not the same. And these are some of the misconceptions that learners do in the exam. Which is wrong. You can only multiply these two if they have the same exponent. You see, if it was like this, if it was 4 to the exponent of n minus 1 times 3 to the exponent of n minus 1, yes, you can say this is 4 times 3 to the exponent of n minus 1, which will be 12 to the exponent of n minus 1. This will be true. Why? Because the exponents are the same because of this law. I'm just addressing some of the misconceptions that I actually encounter, particularly when I'm marking scripts. These are the things that most learners do. And obviously, it becomes a problem because if a learner continues with this approach, the answers that he or she will be solving will be wrong. So it's very important to learn exponents, understand them. That's why even if you're in grade 12, that's why I usually encourage them to say, if you feel like you have a content gap of grade 11, find a need that you can also get a grade 11 textbook, even a grade 10 textbook, just to remind yourself. It's very important. For example, I actually encourage, like in grade 12, in grade 11, there's a textbook called Platinum Mathematics. Yeah, I think that is the best in terms of, like, if you want to do a revision, in grade 12 want to do a revision, like in terms of the algebra part. I strongly encourage you to do that. Very, very, very important. So we spoke about the law number 1, law 2, law 3. Law 3 is when you have one base with multiple exponents. This one is when we have multiple exponents with, multiple base with one exponent. So you can expand it. And sometimes these two laws, they work together. Imagine you have the following. You have a squared, b to the power of 3, everything to the power of 7. So you can see that here you can, because these two are bases, you can use this law, which has the same exponent. You say this is the same as a squared to the exponent of 7 times b to the power of 3 to the exponent of 7. Power of 7 is power exponent. So you see that by so doing, you use this law. Now, after using, now you are forced to use this one now because it has one base with multiple exponent. So this will be a to the exponent of 2 times 7, which is 14, times b to the exponent of 3 times 7, which is 21. Or you can just go direct to it and multiply. Very important. It's very important to know exponent, ladies and gentlemen. Okay, then we spoke about like the law 1, 2, 3, and 4. Actually, I'm just addressing the most important ones, which I strongly believe that once you know them, then you won't have a content gap in maths. Very important. So, okay, just a minute. Then the other one, I can just call it law number 5, but it's actually an axiom that says any number that is raised to the power of 0, it's always equals to 1. Any number raised to the power of 0, it's always equals to 1, according to exponent. Yet we know that actually the basis shouldn't be a number that is equals to 0 usually, but we can also attest to that, because when we go to university, when we have 0 to the power of 0, it's something called indeterminate under differential calculus. So now we have, like, in terms of law number 5. Law number 5 says when we have a to the power of 0 to the exponent of 0, the answer is always equals to 1. Why is this the case? It's because, look, if we were to prove this, imagine when we say 5 divided by 5. 5 into 5, what is 5 divided by 5 in reality? It's 1. If 5 over 5 is equals to 1, this can be written as an exponent as 5 to the exponent of 1, 5 to the exponent of 1. So I want us to use the division law here to say when the base are the same, we take one base and subtract. So this becomes 1 minus 1. Still, we said this equals to 1. But what is this? Become 5 to the power of 0 equals to 1. So it means any number raised to the power of 0, it's always equals to 1. That's the answer. I strongly believe you're following. And this is very important. Imagine you have something like this: 5 into x to the power of 100, y to the power of 20, z to the power of 99, everything to the power of 0. How do you simplify this? Obviously, this is the number outside the brackets. So we'll just have 5 into. Look at this number. This number, x to the power of 100, y to the power of 20, z to the power of 99 expression, it's raised to the power of 0. So we know that anything raised to the power of 0 is just 1. So it means the final answer is just 5. Very important, guys. Then in terms of the laws, I'll just address the ones that are very important. The issue of, let me just call it law 6, when you're dealing with negative exponents. Imagine we have a raised to the power negative x. According to the laws of exponent, it says when you have a to the exponent of negative x, this is the same as 1 divided by a to the exponent of x. So it means to change the negative exponent, we need to take this expression to the denominator. So when we have 3 to the exponent of -2, it means already there's a 1 here. So this is the same as 1 divided by 3 to the power of 2. Why is this the case? Let's do the proving. Why are we saying a to the exponent of -x is 1 over a to the exponent of x? It's because, look, let's start with the, let's just do that the right-hand side. When you have 1 divided by a to the exponent of x, here we have 1. What did we say about 1? We said any number raised to the power of 0, it's 1. So which means when there is 1, we can put a to the exponent of 0. Because we know in a to the exponent of 0 is just 1. Then we divide it by a to the exponent of x. Now you are having division, we can use division law here. We know division law says when the base are the same, what to do? You take one base and subtract the exponent, so it's going to be 0 minus x. So what are we going to be left with? A to the exponent of -x. That's why we know that these two are equal. Very important. So if you spend more time on these laws, law 1, law 2, law 3, law 4, and law 5 and 6, I'm telling you, when it comes to exponent, you're not gonna struggle. It's very important, ladies and gentlemen, to know the exponents. Very, 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 very important. Then after exponent, you need to familiarize yourself with the surds, particularly, but this one it's relevant for grade 11 and 12. Then also in grade 12, I'm saying 11, you don't have to focus much on surds. Grade 10 and below. Actually, the surds is relevant for grade 11 and 12 and beyond. So in terms of surds we're just referring to expressions that are using radical signs. And guys, it's very important to be able to understand surds. So expressions that are using the radical sign, we usually call them surds. But you must be able to understand what does this mean. So this is called if we were to translate this is the square root or the root of a, square root of a. I'm laughing because there's an answer. If you listen to this word, the square means it has to do with 2. It's the square root of a. But if I do this, what is this? This is called the cubic root. Of a. One can say the third root of a. How about this? This is the 5th root of a. And so on. Now, when we are given, let me talk about the first law of surds. The first law of surds says when you have the nth root, okay, let me just write this because I did not explain. Nth root of a, this is the nth root of a. So if I'm having the nth root of a, this is the same as a to the exponent of 1 over n. This is one of the most important that you need to know. That's why when we say the square root of a, it means there is a 2 here. It's just that when we are writing square root, we do not include it, we don't write it. It means when you say square root, we are referring there's a 2 here. It's the same as this. It's just that we don't write. That's why we call it the square root of a. So it means the square root of a is the same as a. If we put 2 here, and then we put 2. It's going to be a to the exponent of half. That's why now, if we were to prove why are we saying this is true, imagine when we say, what is the square root of 4? Actually, when we say square root of 4, we are just referring to what are the two numbers that which are the same that we can multiply that will give me 4. Obviously, the same numbers will be 2 times 2. Since we are saying what are the two numbers, so it means we are saying 2 times 2 is 4, which means the square root of 4 is 2. Why? Because 2 times 2 is 4. But if I say the cubic root of 8, I'm saying there are 3 numbers. There are 3 numbers that we can multiply to give us 8. Obviously, those 3 numbers, which are the same, we're using the same numbers, going to be 2 times 2 times 2. So we know 2 times 2 times 2, it's 8. Which means the cubic root of 8, it's 2. The cubic root of 8 is 2. Why are we saying the cubic root of 8 is 2? Is because 2 times 3 times 2 times 2, 3 times, that will be 8. And say, yes, that will be 8. So which means the cubic root of 8, it's 2. That's why if we want to prove that when we say the root of 4 is the same as 4 to the power of half, we know the square root of 4 is 2. Now let's reprove this. If we were to change, you see, we change sad to an exponent now. It's now an exponent. The exponent is half, the base is 4. But we know 4 can be written as 2 to the power of 2. So we can write this as 2 to the power of 2, everything to the power of half. What did we introduce here? We introduced the law of exponents where we have one base with multiple exponents, which is law number 3. And that says if this is the case, we need to multiply the exponent. It's going to be 2 times half. And what is 2 times half? It's 1. You see, that's why the answer becomes 2. So you must know that the square root of a is just a to the exponent of half. Very important. Very, very, very important. And this does not apply to the a only, the square root of a. It can also be applied to the fifth root, the third root. It depends with what you are given. Very important in exponents and sides. So these are important when you're dealing with sides. For example, the third root of 8 is the same as 8 to the exponent of 1 over 3. But we know 8 is the same as 2 to the power of 3. Because 2 times 2 times 2 is 8. But still, when you see, we are using that law that I said, law number 2, base with multiple exponents, very important in maths. So this is the same as 2 to the power of 3 times half. Oh, I'm saying 1 over 3. So you see, 3 times 1 over 3 is just 1. So it means the final answer is 2. Very important. It's very, 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 very important. You need to be able to know this, SARS, ladies and gentlemen. SARS are important. For example, the fifth root of a, this is just a to the exponent of 1. So it means by changing a SARS to this, it's now becoming an exponent. And you know the laws of exponents. So it's very important. So make sure that you understand the laws very well, ladies and gentlemen. Okay, then the second one, it's in terms of the size, it says the square root of a times b, multiple expression in the radical side. This is the same as square root of a alone multiplied by the square root of b, and this is very important. The root of a times b is the same as root of a alone multiplied by root of b alone. And number 3 is that one I'm saying the nth root of both a and b, which is much the same as this, just that there's a 2a. This is the same as the nth root of a times the nth root of b. Imagine when we want to expand this without using a calculator, the root of 32. Obviously, if you press your calculator, the root of 32, it will say it's 4 root 2. But the question is, how did the calculator got the answer? Then it means now we're going to do this. We have to actually use things like, you must be able to understand what we call by the perfect square numbers. The perfect square numbers we are referring to 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. These are perfect square numbers. So this 4, 9, 16, 25, 36. These are perfect square numbers, so that if we were to put a square root here, we know the square root of 4 would just be 2. Square root of 9 would be 3. So it's very important when we are solving this, you must use perfect square numbers. For example, we're going to search for 2 numbers of 32 that we can, factors of 32 that we can multiply to give 32, but one of the numbers should be a perfect square number. Already 32 is the same as 16 times 2. We can use 16 times 2. Why do I use 16 and 2? 16 is a perfect square number. So it means this is the same as 16 times 2. So I'm using the a and the b. We're using this. There is the a and the b. And this can be written as root 16 times root 2. Very important. And 16 is a perfect square number. Root of 16 is 4. And root of 2, it is an irrational number. It means that the answer will be in decimal. So it will be, we'll just leave it as root 2. So the answer becomes 4 root 2. It's very important to know this laws. Very important. It's very, 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 very important to know this. Especially number 1 and number 2. Very important. Then the other one is the issue of the nth root when we're having a fraction, but it still applies. This is the same as the nth root of a divided by the nth root of b. But don't forget the nth root is just a to the power 1 over n and b to the power 1 over n. You can still expand it in that way. There's no problem, but this is the key, guys. Especially the SADs who are in grade 12. If you're going to do calculus, a chapter called differential calculus, you need to be able to know SADs, exponent, exponent and SADs. Very, 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 very important. So I'm just actually addressing the ones that are important for you to score a lot of marks in maths. Very important, ladies and gentlemen. And another thing is the issue of the algebraic expressions, ladies and gentlemen. Under algebraic expressions, one must be able to understand what you mean by a binomial, a monomial, a trinomial. We know a binomial is just an algebraic expression that has one term. I'm saying a monomial, yes. Then binomial is the one that has 2 terms. And remember, a term is identified, it's separated by a plus or minus. Then again, you need to be able to know the coefficients, very important, of an expression, the constants. For example, if we were to talk about this, because you find that, yeah, if we let's say under algebraic expression, if I say 2x squared plus 4x plus 9, this is an algebraic expression. And this algebraic expression has 3 terms. How did I say that? A term is separated by a plus or a minus. If there's a plus or a minus, then we can be able to identify a term. So it means if we have multiplication or division, then that thing to combine, it's just one term. So this has 3 terms. And we know an expression that has 3 terms called a trinomial. You have done this in grade. That's what I'm saying. Whether in grade 12 or 11, if you're still struggling with expansions or whatsoever, you must be able to understand this. And within this, we have variables here, x. These are variables. Why are we calling them variables? It means they can change at any time. So they're just expressions that are changing. And this one without a variable, it's called a constant. Which means when we are talking about a coefficient, we're referring to a number or a quantity, a number or a quantity that comes before a variable. So which means if this is the variable, there's a number here. There's a number. These are called coefficient, which means 2, it is the coefficient of x squared. Then 4, it is the coefficient of x. Very important. And the other one is the issue of knowing the highest degree of the expression. When you talk about the highest degree, we are referring to, like, what is the highest exponent on this expression? This one has an exponent of 2. This one has an exponent of 1. So this one, it has the highest degree power of 2. And we know the one that has the highest degree power of 2 is called a quadratic equation. It's called quadratic. But if we have, let's say we have x cubic plus 3x squared plus 9x plus, let's say, minus 7. How many terms are here? 1, 2, 3, 4. So it's 4 terms. It means this fall under polynomial. Now, what is the highest power degree here? So one has power of 3, 2, 1, 0. Then it means the highest power degree is 3. So it means this is a cubic. It's a cubic. So it's very important for a learner to be able to know the algebraic expressions very well. But sometimes the exam will say, what is the, like when you are solving coefficient of x squared, coefficient of x cubic, you don't even know that, but it becomes a problem. So it's very important to understand this. Whether in grade 11, 10, 12, you have to know this. Very important. And the other thing, guys, is the issue of identifying like terms. Like terms and unlike terms are very important in exponents. Not necessarily in exponent, but in maths. So be able to identify like terms and unlike terms. It's very, very important. For example, let me just give a simple practical example. Imagine we have the following. You have an apple and a banana, and you want to combine these two. What will be apple plus banana if you were to add them together? Obvious, you cannot say apple banana because these two things are unlike. They're unlike. So it will just be apple plus banana. But if you have an apple, you combine with an apple. Yes, because in reality, this will just be 2 apples because they are now in plural form. But mathematically, remember we said x is just a variable which can stand for anything. So it means we can say wherever there's an apple, let's put x to represent an apple. Banana, y. So you see, as we are changing this to say, you are taking x, you are adding it with y. You're taking an apple, adding with banana, it will still be x plus y. There is no way you can say this is xy. That does not make sense. But if you have an apple with an apple, then you have an apple, it's x. With another apple, it's x. Then it's going to be 2x. It's just that we cannot put the s there, like as in English. But this is math. This is math. You see, x with x is 2x because there's a 1 here and there is a 1 here. So 1x plus 1x is 2x. You see, these are the things that most learners struggle with. That's why, look at this. If we have x squared plus x squared, can you say this is the same as x to the power 4? The answer is no. Why? There is no law for exponents that is to do with addition. And x squared and x squared, these are like terms. So it means there is a 1 here and there is a 1 here. So it's like having apple with apple. So this will just be 2x squared. These are things that most learners, you see, most learners that actually, like most of the learners that actually meet, most of them, you find that they're struggling with these things, which means they have a content gap. So it's very important for a learner to be able to identify the like terms and the unlike terms. But in the context of multiplying, apple multiplied by banana will just be apple times banana. That's why we say x times y is just xy, because these are unlike terms. So you need to be able to understand these things very well, ladies and gentlemen. And sometimes the issue of multiplying, getting the product, and this is grade 10 work, but you find a learner in grade 12 not be able to multiply expressions. For example, imagine we have the following: x plus 2 times x plus 3. Find the product. And this is algebra. Yes, there are different ways you can use FOIL, which most learners are used to. But look, from grade 10, you used to do this. To say, when you have x plus 2 and x plus 3, you can do something called distribution law. To say, we take this, we take the x, we open the brackets, we close, plus we take 2, we open brackets, we close. So I've just used this one. Then now this time around, I'm going to put this one here and put that one there. This will be x plus 3 and x plus 3. Then let's do the multiplication now. It means the x is, because it's outside, it will affect the x inside and the 3. So we're doing the multiplication. Now, remember I said why multiplication is because the brackets. What is x times x? Now it comes with the exponent. This becomes x squared. Plus, what is 3 times x? This is 3x. Plus, what is 2? We remove the brackets this time, we times here. What is 2 times x? This is 2x. 2 times 3 is 6. Now, that's where we need to group like terms. So this becomes, you see, this is not a like term of any, so it means we're going to have x squared. We have 3 apples, we're adding with 2 apples. Obviously, we're adding, this will be 5 apples, but it will be x plus 6. This is the answer. But when you're using FOIL, it means you have to do this x plus, it's the same as that, but it's just that you're not aware. Let me show you something. Look what we did here. We've taken x in these open brackets, and we put this. Also taken 2 open bracket. So it means the same as when we have this x, you multiply by the whole of this initially. Let's do it. X with x, x squared. X with 3, 3x. Then we're done with x. Then we come to 2. Multiply inside. 2 times x, 2x. 2 times 3, 6. You see, it's just a shorter way of getting the answer. But you find a learner struggling with this, and it becomes a challenge, especially when it comes to this. Imagine if you have x plus 3, x plus 3, and x plus 3. You can even use the grade 10 method. There's no problem. What matters is we want you to get the answer. How? It does not matter. Whether you use the long approach or what matters is you understand what you're doing. For it's either use FOIL first, outers, inners, and the last. It's the same as the second one. Because you find a learner not being able to expand this. And this is maths actually. You need to be able to understand it very well. And you see, that's what I'm saying. You be using all the whether grade 10, 11, and 12. Obvious, it's straightforward with this one. What you can do, you can just do this. Because you have 3, you have binomial. Maybe you can work with 2 first. Take 2 and work with them first. Either you are using the bracket approach or it does not matter. Open, close, plus 3, open, close. Then here you put the second one. So it's x plus 3 and x plus 3. This will give us x squared, 3x, 9, 3 by 3, 3x, 9, 3 by 3. So this we group like terms. These are like terms. We're going to have x squared plus 6x plus 9. We're no longer multiplying, we're just grouping. So you see, we're just multiplying these two only. So you're going to remain with this x plus 3, the first one. And these two are now is the way you say x squared plus 6x plus 9. You see, this time around, it means you can still do this. Take this one, x, open, close. Take the 3, open, close. Then you're going to have x squared plus 6x plus 9. X squared plus 6x plus 9. Or you do the multiplication in each. There's no problem. So this will become, you see, x and x squared, this x to the power of 3 plus x times 6x, this becomes 6x squared exponent. X times 9, these are just 9x plus 3 times x squared is 3x squared. 3 times 6x, this is 18x plus 3 times 9, this is 27. Then after this, that's why you have to group the like terms. You check x cubic, you don't have any, so it's going to be x cubic plus this and these are like terms. You see apple and apple. So 6 plus 3, this is 9x squared. And same applies, these two are also like terms. 9x and 18x, this is 27x plus 27. Many ways to skin a cat. Exponents are very important, ladies and gentlemen. Exponents are very important. And the other thing is the issue of being able to understand. For example, imagine you have, I think having a good background from grade 10, you're not going to battle with this. And if you feel like you're still battling with this, I strongly encourage you to visit grade 10 textbook. It's very important, especially the classroom maths. If you can just get the grade 10 classroom maths, it has a lot of examples where you'll be able to, because Elena, you find that Elena is struggling with factorization. For example, in like maths has its own terminologies. The likes of sum, which has to do with addition. The likes of difference, which has to do with subtraction. Quotient, division. Like, for example, if I say, what is the sum of x and y? So it means you have to just take x and y, you add. But if I say, what is the sum of the square of x and y? So it means here it's still a plus, but the x and y should be squared. So this is the sum between two squares. But if I say, what is the sum between two cubes? So it means a cube, remember it's x to the power of 3. And y, so these are cubes. So if this is the sum between two cubes. And in terms of the difference, it's just the opposite. X minus the difference between x and y. The difference between two squares. And always when we have the difference between two, we'll talk about and the difference between two cubic. And this is maths, guys, you need to be able to understand. And wherever you have, if we can have x plus y and x minus y, you must know always that once you take two expressions that are actually the same but differ with the sign, they will always give you the difference between two squares. So it means this one is the same as x squared minus y squared. So it means in future you must know, okay, when I'm given this, say, for example, let's remultiply, whether using FOIL or the other one. So if we remultiply, we take this, we multiply by the whole of these two. So x and x, this becomes x squared. X and negative y, this becomes negative xy. Then now we are done with this. Now we use this y with x. It's yx, but we can write algebraical to say alphabetically xy. Then y with negative, so this is negative y squared. You see, we group the like terms. This is a minus 1 plus 1. These are like terms. Minus 1 plus 1 is 0, so you're going to remain with this. So it means always, for example, if you're given x squared minus 9, this is the difference between two squared because x squared minus 9 is 3 squared. It's the difference between two squared. X squared minus 4. This is also the difference because it's x squared minus 2 squared. It's the difference between two squared. X squared minus 16. Also, this is the difference, which is going to be x squared minus 4. You see, these things are straightforward. You see, for example, if you say x squared minus 81, this is the difference between two squared because it's x squared. 81, it's 9 squared. So it means by having this, you must know I will have the same sign, the same expression, but with different sign. So it's just this, open brackets, x, 3, 3, negative and positive. Same applies with this. So it's going to be x minus 2, x plus 2. Easy. This one, x minus 4, x plus 4. This one, x minus 9, x plus 9. Always the difference between two squares. And these are exam typical equations. And these are exam typical equations. And again, sometimes they can give you this. For example, they can give you the difference between two cubic or the sum between two cubic. They say expand it. The difference between two cubic or the sum between two cubic. It's also important in algebra. There are a lot of things that I can address here, but for now, I'll just focus on exponential sides and algebraic expressions. Okay. Look, imagine you are given this. As I said, you can also visit the grade 10 textbook just to remind yourself. Look, imagine you have the following. You have x cubic minus y cubic. You want to expand this. This is the difference because there's a minus, the difference between 2 cube. And this straightforward. What do you do? It means the difference between 2 cube will always give you a binomial and a trinomial. So you must get a binomial and a trinomial. Let me also do this. X cubic plus y cubic. Same applies, binomial and trinomial. How do you do this? Straightforward. You look at this. First, you have the x -1. What do? You put the x here and the y. If the sign is negative, you just put the negative there. Here, you just put the x and the y. If sign is positive, you just put the sign as positive there. So it means this one and the sign are always the same. Then let's come this side. If you said you used x and y, we have x to the power of 3 here, which is the same as x times x times x. Already we used 1x here. It means you're going to have x squared here. Because x squared times x is x cubic. Then if we use 1y, it means you're going to have y squared. Look, here is the secret. You write y squared. So same applies, you're going to write x squared here. And then you're going to write y squared. Then you do this. Always here, you write a plus. This plus and a plus. Here's the secret. We want the middle term. Look how we're going to get the middle term. To get the middle term, we take these two, we multiply them. What is x times y? It's xy. Then what is the sign here? Negative. So if it's negative, we'll do the opposite. It's going to be a plus. We come here, do the same. X times y, xy. What is the sign here? Positive here, we do the negative. That's why if we can take this, let's take x minus y together with x squared plus xy plus y squared. We use the long method. The long method means we now take x, we open, we close. We now take negative y, open, we close. Also, sorry, I apologize. Open, close. Then here, we're going to substitute by this. This will be x squared plus xy. You must know both the method because somewhere in the exam you might find you can do it on a rough paper if you don't want to show all your workings. But remember, practice makes perfect. Then we do the multiplication inside one by one. So x with x, this will become x to the power of 3. X times x, this becomes x squared with the y. X with y squared, this becomes xy squared because these are unlike terms. Now we multiply by negative, and something I forgot to introduce, guys. When we are doing the multiplication, if you're taking negative, you multiply with negative. Or you're taking positive, you multiply with positive. The sign will always be the same, it will be positive. But if you are using opposite sign, negative, you are multiplying with positive. Or you are taking positive, you are multiplying with negative. Always the sign will be negative. So here we're going to multiply together with the negative. This will be negative x squared y. Positive times negative, this will be negative x, y times y is y squared. Negative times positive is negative. Then what is y times y squared? Exponents, y to the exponent of 3. Exponent, then we group the like terms. Let's group the like terms. X cubic, we don't have any other than we know. If it is x cubic, let's check here. This one here, it is a like term for this one. So there is a 1 there, and there is a minus 1. So what is 1 minus 1? This will become 0. And same applies. These two are also like terms because it's 1 there and 1. So it's a plus 1 and negative 1. Plus 1 minus 1 is 0. It becomes 0. Going to remain with these two only. You see, a cubic, I apologize. You see that is the same as this one. So you need to be able to know this, ladies and gentlemen. And also, this is also important for first-year university candidates. Very important. Very, 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 very important, ladies and gentlemen. And another thing is the issue of taking a common factor. Very important. Common factors are very important in maths. Be able to take common factor. For example, if we say we have 2xy plus 2x, It's a binomial, this expression. And there's something common here. What is that? On this 2, there's a 2 and there's a 2. There is an x, there is an x. So if we are taking that common factor out, if we are taking 2x, I'm taking this now. What I'm going to remain with? Obviously, I'm going to remain with y plus. If I'm taking this, I'm not going to remain with 0 because there's a 1 here. I'm going to remain with 1 because if I remain with 0, when I multiply back, it will no longer be the same as that. So I'm going to remain with 1. Common factors are very important in the exam. For example, those who are in grade 12, they can say to you, solve for x. Then you have, let's say you have x squared plus 4x equals to 0. Obviously, just having binomial. In binomial, we have a common factor because x squared is the same as x times x. You see, there is an x here, and there's also an x there. So it means the common factor there is x. So if I'm taking x here, I'm going to remain with x. Then here, I'm going to remain with 4. Very important. Common factors are very important. That's what I'm saying. It's all about practicing. If you feel like you still have a content gap, it's either you in terms of algebra, you can get a grade 10. This book, you just go straight to algebraic expressions. Try to go and master them. If need be, you can even get someone who can assist you. So actually, I'm also attesting to the grade 10s to say, please, if you're in grade 10, make sure that you listen to your educators whenever they're teaching, so that you're able, like these gaps, you mustn't have these gaps when you're in grade 12. Very important, ladies and gentlemen. So it's not the only thing. We can also focus on the issue of fractions, be able to simplify fractions and some stuffs. So it's very, 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 very important to be able to understand this. Because once you are able to know this, it's easier to understand how to factorize. Factorization, which will be a video for another day. Factorization, very, very, very important, ladies and gentlemen. Okay, thank you for listening, guys. And I strongly believe you will benefit from this video. Thank you very much. Bye-bye.